Hey everybody, how you doing? Welcome to Howdy Partner. For those who are joining us for the first time ever, Howdy Partner is a weekly Twitch series highlighting AWS partners, network technology partners that have built innovative solutions that have been validated by solutions architects of AWS. So each episode explores a different APN technology partner solution and how you can implement it with your workloads. Today we have with us Neve from Chef, and I also have my co-host here, Stuti. So why don't you two go ahead and introduce yourselves real quick?
Sure, I'll go first. So my name's Neve Cahill. I've worked at Chef for about 3.5 years at this point. I lead the solutions architects team at Chef. Love it there. I get to talk to lots of different Chef users and customers all around the world. So I think it's a really cool job.
Awesome.
Hey everyone, this is Stuti Deshpande, and same as Braeden, I'm a partner solutions architect at AWS. And like Braeden, I work with different partners and interact with them with the webinars and Twitch shows. Really excited to be here today with the Chef and looking forward to it.
Awesome. Well, we'll go ahead and just get right into it. Neve, what are we going to be talking about today? And, how can we go ahead and get started?
Yeah, so we're going to focus on two different topics. They're kind of two different aspects of the same thing. So as you're deploying updates, whether it's applications or infrastructure into your environment, testing and validating those configurations and deployments, it's a challenge. And there's lots of different solutions and ways to achieve that out there. But what we're going to do is basically approach how do you get out the door with infrastructure as code in Chef, and how do you programmatically build that into your deployment pipelines. And first, we're going to look at building AMIs, so Amazon Machine Image, using AWS code pipelines, along with Packer, and how to do that programmatically and what the different components are. Because I think that when you break it down, the building blocks are fairly straightforward, but it's just understanding what that overall flow is can sometimes be a bit challenging. And the second topic we're going to focus on today is really focusing on Chef Inspec. So Inspecs is really cool tool that you can use for lots of different things. And today we're going to be looking at using it as part of an AWS Lambda function. Inspec's very widely used in terms of functional and compliance testing for your configurations and your applications. And we're going to look at overall, well, what is Inspec? Why would you even care about that? And then we'll talk about, the different flexible ways you can use Inspec. And one of those ways is AWS Lambda, which is pretty cool. So yeah, those are the two subjects we're going to be covering today. And then, if anyone has any areas they want to dive into for details, just put your hands up in the comments. And, Stuti and Braeden, if you see any comments in there that I don't see, feel free to interject. And
absolutely, yes, we will. Any questions you all have, we'll raise up to Neve, and she'll be able to answer them. So we'll be interrupting quite frequently, Neve.
Cool. Yeah, interactive is better for sure.
Sure.
Cool.
All right. So with that, let me go ahead and add your desktop here. Is it prepared?
It is.
Okay. So let me go ahead and add it. There we go. Up a little bit of inception here. There we go.
There you go. Yep. Cool. So I am not going to PowerPoint anybody to death here. I just wanted to share a couple of quick slides just to frame up what we're going to be talking about today. So I think a lot of people have heard of Chef, and we usually talk about Chef in terms of Chef, Puppet, Ansible, and SaltStack, of course, in that context. And traditionally, Chef focused a lot on infrastructure configuration and automating server configs and application deployments, which we still do. That's still the heart of the Chef solution. But we've also added on other capabilities as well. And I wanted to make sure that we kind of took a quick look at what those different components are of the Chef solution stack, so you all understand what I'm going to be showing today, right? And we're going to go lower level and go into code level detail during the session today. But, overall, there's 3 core components to the Chef solution. The first is Chef Infra. So that's the Chef you all know and love. It includes Chef cookbooks, components like Chef Server, etc. There's a lot of different ways to run Chef at this point, just from a pure configuration perspective. So we'll talk about different ways to kind of plug Chef into a deployment pipeline scenario today. The second component is Chef Inspec. Chef acquired Inspec back in 2018, I want to say. And Inspec's really cool. So it is an evolution of Server Spec. And what it does is, Inspec doesn't care how you're delivering change. You could be using Ansible, you could be using straight up scripts and CloudFormation templates. It straight up doesn't care. Basically, what Inspec allows you to do is to describe what your configurations should be and validate that what you're deploying aligns to those standards. And so you can leverage Inspec to do functional testing as well as compliance checks. And what's really interesting is Inspec's become kind of a de facto standard language for config checks and compliance checks across the board. So I see a lot of Inspec users and Inspec customers out there. For example, DISA, the government agency, they use Inspec to specify what their STIG standards should be for deployments within the US government. I see a lot of collaboration around different best practices for config. So we're going to be talking a lot about that and how you can leverage Chef Inspec. The first cousin of Inspec is Test Kitchen, and we're not going to be showing Test Kitchen today, but just to make you all aware of it, it is not a project that Chef owns or runs, but we do contribute to it. And what Test Kitchen allows you to do is to spin up containers for testing or virtual server instances on AWS, or you can actually test your configs locally against a container that's running on your laptop. There's a ton of different ways to approach that, but both of those testing mechanisms, essentially understand to look for Inspec tests in a certain location in your deployments and run those automatically. And we'll take a look at what that structure looks like. And finally, there's Habitat. Now, we're not really going to focus on Habitat. Habitat is a whole world unto itself. We can literally spend 3 hours chatting about it. Habitat is our application deployment layer. We have a lot of users and customers who are essentially using Habitat to do app deployments in, edge environments, so hardened environments like factory floors and retail environments and things like that. And then finally, having visibility into all that stuff. So the Chef Automate layer, that's where we're going to start out today, just to kind of give you an idea of what these building blocks look like, if you're not deeply familiar with Chef already. And then we're going to go from there into greater detail. So cool. So just to give you a quick overview of what our architecture looks like, what we're going to be doing today is we're going to be looking at hardened image pipelines. And at Chef, we work very closely with HashiCorp. And today we're going to be leveraging a solution called Packer. So if you're not familiar with Packer, HashiCorp's also an AWS partner. They're awesome. And essentially, Packer's really straightforward way of programmatically building server images. So it works equally well for on-prem as it does in the cloud. With AMIs, it makes things very straightforward. And the nice thing about Packer is Chef plugs right in as a builder within Packer. So you can define your base configurations, and then you can validate them with Chef Inspec. And we're going to go through what this actual overall process and code looks like. But if we go back to this original architectural diagram here, what this is showing is essentially if you're deploying change into your environment, what does that look like from a Chef cookbook perspective? How do you validate that with Chef Inspec? How do you make sure that you're compliant on an ongoing basis? And as you're deploying that change, all of it is reporting up into our Chef Automate server. And And the Chef Automate server, basically all that inbound traffic is HTTPS. One of the nice things about Chef is it's really flexible from an architecture perspective. So if you have, for example, an inspect check running in a Lambda function like we're going to show today, essentially you can tell inspect to send those results anywhere. You can tell inspect to send the results into AWS Security Manager, as well as Chef Automate. So we can think of inspect in terms of inputs and outputs, with the inputs being, here are the configs I want to check, here's how I check them. So if you're checking a container, for example, inspect will know to use, for example, the Docker API or the Kubernetes kubectl commands to check that. And then the outputs can be JSON, they can be HTML. Inspect really doesn't care, where you want to send the outputs, and you can specify that and just say, yes, as part of my pipeline, I ran this check and it passed, so we deployed, or it failed and we stopped the pipeline. So any questions there, anyone?
This looks exciting. Like this, yeah, I'm excited to dive into this, Neve.
Cool, awesome. So with that said, I am going to do a quick overview of what our UI looks like. So Chef Automate, there's two components to the front end of Chef. One is Chef Server, which is just our traditional component for really storing versions of cookbooks, keeping track of what all we're managing. There's a lot of different capabilities there. But our UI layer essentially is Chef Automate. And what that gives you visibility into is, what do you have deployed in terms of just regular servers that you're managing with Chef? And then from a compliance and a configuration check perspective, what are we checking against? And basically that's reporting back in here into the compliance tab. So we have two different dashboard or data sections. We're going to start with basically the infrastructure section here. So more traditional environment, obviously. And the reason I'm sharing this is we're going to be showing how you run a Chef cookbook to do base configurations on an AMI, and then how you can deliver additional changes with a cookbook like that. And when you manage a node with Chef, essentially, you're doing that by putting it into a group that defines which configurations get deployed to that particular group of servers. And that's what you're looking at here in terms of policy groups. So a policy group could be, you can have really as many policy groups as you want. This particular one here are my Red Hat development machines. And then beneath that, I have my development Windows machines. And we're going to talk a little bit about, I think the question I get most often is, okay, on Learn Chef, which is our learning website, you show how to bootstrap one individual node manually. But how would you get out the door with this at scale? And that's really where we talk about programmatically building AMIs, or the other approach that we use in conjunction with that is leveraging user data. So the user data scripts, when you're spinning up EC2 instances, I think they're great. There are configurations sometimes that you're going to want to deploy or are going to want to lay down only at deploy time. So for example, if you have an Nginx host, you might want certain configurations or parameters to be laid down, once you know what the host name of that host is, etc. So there's certain application layer configs that can be dependent on that kind of information. But essentially, if we look into each of our nodes that we are managing with Chef, you'll see we have all the stuff that we're managing with Chef. We have 18 unchanged settings here. So what we're looking at here is when you initially install Chef client on a node and you have Chef manage a set of configurations, Chef evaluates what it needs to change, and it doesn't change or update anything that is already at the right setting. So for example here, obviously, when we first lay down Chef, we create these directories, etc. And you'll see here, there's this concept of resources. So a resource is a Chef building block, right? So what this does is, for example, if we already had the directory Etsy Chef on this particular node, we're not going to recreate it, right? But if you went back to the very first time I ran my cookbooks on this particular server, and this would typically be at deploy time for what it's worth, you'll see that there's definitely changes that I've made. There should be, rather. Yeah. There we go. So as we're going through, you'll see that you can add in cookbooks or additional cookbooks or update different parameters in an infrastructure as code manner. And then as things get updated and changed, that's captured in the run history. So if we look into run list, we'll see we have just Chef client that got laid down. And let's see a different node here. I want to look at a Windows node really quickly. You'll see we had 11 successful changes. And again, I've just filtered down to what was successfully changed. But say, for example, you had a registry key on a Windows machine that you needed to create. We only create this if that registry key has not already been created. The other thing that's really cool is you have the ability to do templating around configurations, and you can interpolate variables in those templates as well. And where that becomes cool is, for example, if you had a template for your Windows audit policy or for your local account policies on your Windows server, and you wanted to make sure that was absolutely consistent across the board, you could have that as a template version in your cookbook. And then if we look at unchanged, these are all the other things that we originally configured with Chef. And typically the way that folks are using Chef, it depends, right, on whether you're running an immutable infrastructure approach or not. But Chef will run periodically on your node, is the traditional way of running Chef. I'm going to talk a little bit about how there's other patterns that you can definitely use at this point, especially with the advent of immutable infrastructure. But basically, the idea is we're running on a periodic basis, maybe every 30 minutes, maybe every 6 hours, depending on your environment. And if somebody changes something that they shouldn't, it will just be flipped back to what it should be with Chef. So say, for example, you updated httpd.conf on a Linux box, the Chef template's going to, once Chef client executes, it's going to flip that setting back to what it used to be. So we're really enforcing that desired state.
Neve, I actually had a question about that. So will that happen automatically? It'll detect it automatically and flip it? Or do we have to wait the allowed amount? You know, if it's running every 30 minutes, we have to wait, you know, the full slot of 30 minutes before it gets changed back?
So typically, and this is actually why I was saying there's other ways to use Chef at this point. Typically, you would have to wait until the next Chef client run. Cool. Now, what we're seeing more and more, and what we've really started to build into our architectural patterns, is the ability to trigger a Chef client run with a specific set of cookbooks based on external parameters. It could be a deployment pipeline. It could be some kind of update you want to do that's out of band. Let's see what else. You know, it might be a Friday evening and somebody needs to troubleshoot something, and you have a set of cookbooks that does that for you. You can trigger a Chef client run basically out of band, or, you know, outside of the regular Chef client run by leveraging that policy files concept. So if you look at this policy name, that base win, what you actually have the ability to do is, when we start looking at the pipelines, there's this concept of running Chef without a Chef server, because Chef server essentially keeps versions of the cookbooks and tells the Chef clients what to run. If we take that out of the equation, we now have the ability to, with policy files, we have the ability to just essentially run a bundle of cookbooks locally on a node, or run a bundle of cookbooks as part of a pipeline, we can be really, really specific about what we're running at a specific point in time. And I work with a lot of customers who are absolutely using Chef in that way. We mentioned Habitat at the beginning. We're also layering in Habitat at that point to really implement those changes right away. In a scenario where you might have an issue where somebody changed something you didn't want them to, you can have a detection that's going to work through Inspec, and you can have that trigger a Chef client hardening run at that point as well.
Cool.
So lots of flexibility there. The other thing that's really cool and how we understand what needs to be changed on the node is we gather a lot of different information about everything that we're managing. And these are all attributes. So essentially, this is Windows, so we're checking to see if it's Hyper-V, audit attributes. The first set here is more Chef, but if we scroll down, you'll see all kinds of information about Chef client. If it's an EC2 instance, we gather all the EC2 information. And this is part of the Automate solution. It's stored, and you can leverage this and actually send this information out to third-party systems. There's a number of different ways to leverage this, but typically you can turn on a data tap at the Chef Automate layer that will stream that data out to other solutions. A lot of folks are streaming it out to that. Automate is actually Elasticsearch, but they're streaming the data out to their own Elasticsearch. There's a couple of different ways to deploy. So it's pretty clear, or pretty cool from that perspective. You can see your availability zone in here. So if you wanted to have a clear idea of, what number of servers or footprint you had deployed, what packages are deployed on those servers, that kind of thing, what versions of everything are deployed, you can capture all of that in here. And then as those configs update, whether or not they're managed by Chef, essentially that information will be reported back in here each time the Chef client runs. So pretty cool from that perspective. And then on the Inspec side, what I'm going to do is I'm going to go back in time in my timeline. I don't have a very big environment here, but what we can do is click on one of these and go back to where, I don't know if Stuti and Braeden, if you remember when we were half an hour ago when we were getting ready, I clicked on a link to update this environment, and it went out, and what I was doing was actually running a hardening job on these servers that went out and basically fixed all of the configurations for them across the board to align it to CIS compliance. So,
wow.
Yeah, and it's honestly, once you've defined your standards, and by the way, Chef, infrastructure as code's all fine and well, but very often I think the challenge is there's not enough time in the day, right, to sit down and write all this code, or it can be challenging. And Chef, really, we have a library of content on the compliance side that says these are the standards that you should be using for, for your cloud environments, for containers, for servers, for different application stacks. That is predefined for you. And then we bring that versioning and infrastructure as code approach to those standards. So, for example, you might have one very hardened set of configs you want to deploy to production, but then for your dev and your back end, you might have something that's a little more loosey-goosey. So we allow you the ability to align your standards to the different environments that you're deploying.
Sure.
So here's what was happening, and I'm running Inspec against this server. In this scenario, I'm running Inspec through Chef Client. Now, what we're going to look at today are all the numerous ways you can actually use Chef Inspec. But what Chef Inspec is, it's a pretty straightforward way of describing what the configuration should be on your environment. And if we look here, we'll see security policy password history size is expected to be greater than or equal to 24. And if we look at the source code for that, by the way, we ship the source code and you can edit all of this in versions. So that's what I mean by that. when you look at this parameter, its password history size should be greater than or equal to 24. Inspec understands what password history size means on a Windows machine, and it knows what parameter to go and check for that value. And that's the same across the board. So for example, when we start checking containers, it understands what the different settings are for your container images, as well as a running container. And so very frequently we have folks who are leveraging Inspec as part of their container build pipelines to do these very functional checks and parameters as part of that. So when I'm saying, yeah, you can use Inspec as part of a pipeline, this is really the heart of what it does. So if we go down through a few other checks that we've done, so I can't lock out duration is 15 minutes or more. This is pretty, it wasn't defined, which who knows what default setting is the case for this then. And we always like set to what the CIS compliance benchmark is. You can add in your own tags for all of these. So you can tag at the compliance or the configuration check layer. You can also tag your EC2 instances if you want to as well. And we also understand AWS tags. So, you know, when we're talking about running inspect checks, what you can actually do is you can run a scan job into your AWS environment, and you can say, scan and run an inspect check against all of my EC2 instances that have these specific tags. And I think that the key there is having the right access roles defined for those scan jobs. And that's where, you know, functionality like the running inspect in a Lambda function really becomes pretty cool.
If we had a quick comment in the chat here, are you able to zoom in a little bit so we can see those? See some of those logs a little better.
Yeah, let me see here. Is that a bit better? I know it's probably still pretty small.
I believe so. I think let's take a look at it. If you are able to like zoom in just a tad more, that might be helpful. I know for you, it's probably ginormous right now.
No, it's totally fine. Hang on.
Oh, there we go. Looking better. If you're able to do 150, that I think would be best. If not, then that's fine too.
So
cool.
I think this looks really great.
Good. All right.
Cool. Okay. Perfect. So the way that Inspec achieves this is it's broken out to we call controls, and controls are essentially configuration tests. And that's why you can use Inspec for compliance, or you can use it for functional testing of your infrastructure as code. And if you Google Inspec and CloudFormation or Inspec and Terraform, you get lots of results back of different projects that folks have done down through the years to leverage Inspec in different scenarios. And so if we look at all of our fail controls here and scroll down, this is what I was talking about in terms of lockout duration. But the same is true across the board, whether you're looking at Red Hat or Windows or Apache, Tomcat. There's lots and lots of different parameters that we can check. Give me a sec. I'm going to go into a Red Hat example here really quickly. And so you're looking at a server that I already hardened. So what we'll do is we'll go through and we make sure that essentially all these extraneous file systems that you really shouldn't have enabled are turned off, for example. Making sure that package manager repositories are configured properly. So that is a setting we can configure, and we can talk about this as part of the image pipeline as well. But basically, the image pipeline, that is something you can leverage Chef for. So Chef can go out and talk to your package manager and lay down a certain set of application packages or patches if it's Windows and you want to have a consistent patch set, right? So let's go through here. Ensure core dumps are restricted. That's usually a pretty good one. So rather than you having to go in and write all of this, we understand how to parse kernel parameters, and you can basically check any content in different files. If you want to get fancy with regular expressions, as we did here in this example, you can do that. You can basically go shell out into commands as well, although typically this is a kind of a side scenario. We wouldn't normally do that. But yeah, you can evaluate your different kernel parameters and make sure that each of them align to what you want to. And essentially this, when we talk about CIS compliance for something like Red Hat, that's fairly well understood standards. But what we've done is codified those across the board and made them pretty straightforward to edit and update through InSpec. And when you're getting out the door with this, basically Chef ships with a whole library of InSpec profiles, so you don't have to go in and write all of these from scratch yourself. So here we have Amazon Linux CIS benchmark level 1 and 2. And then as new updates are published, basically, we'll update these profiles and deliver them so that, you as users and customers can understand exactly what needs to be the configuration as well. So for example, if we went in and did this most recent version, we can go, now we have, that was as simple as I just click get and it copies it over into my UI, and then I can take a look at what exactly is being checked in here. If you look back at actually what this behaves like within our environment, really quickly. Actually, let me go into a Red Hat instance because I think that will show what I want to show to you guys. See where it says skipped controls? So what we have the ability to do is skip certain checks under certain conditions. So I'll give you a really practical example of where that would be the case. So if you had a server and the server's running Docker daemon, you weren't supposed to deploy Docker daemon with that server, but here we are, Docker daemon is configured on there. And this is true of laptops as well, by the way. What we can do is we can say, hey, if we detect that Docker daemon is configured and running, go in and check the settings for everything to do with Docker and make sure that it's compliant, and then report back into Automate. If we're not running Docker on that particular instance, then we'll just skip that control. The other thing that's really cool is we have the ability to assign waivers. So if we wanted to give a legacy application environment a little bit of runway to update certain application libraries or whatever it might be, we have the ability to specify a waiver. And what that does is we say either for this particular compliance profile as a whole or InSpec profile, we can waiver this particular config check and you can specify an expiration date. And then once that expiration date passes, we'll start running that check again. So it's pretty flexible from that perspective. And then obviously every time we run a scan, we send the results back in here. So that's the overall structure. Yeah, go ahead, Stuti, sorry.
Oh, sorry. I actually have a quick question. So in the compliance, you showed that there are a couple of reports as CIS, and I also saw there are some levels associated with those reports. So what are those levels denote? And is there like a priority 1 or priority 2 issue, something like that?
Yeah, so what that is CIS actually stands for Center for Internet Security. And they publish the configuration standards for running hardened servers, cloud environments, application configurations. What level 1 and level 2 mean is level 1 is slightly less stringent than level 2. I believe level 2 might turn off things like SSH and other management layers entirely that you might typically, I think everybody needs access to that. So that's the difference. And then if you actually scroll down to the bottom of our library here, I just want to highlight a similar situation that we see with what's called STIG. So STIG aligns to the US federal government config recommendations. And I'm sure a lot of you sitting there rolling your eyes going, well, I don't need to worry about what the federal government wants in terms of config. But every now and then what will happen is you'll need to deploy a FedRAMP certified environment. And these are called STIGs, so Security Technical Implementation Guide. And essentially those STIG recommendations, if you use those checks in your own environment to ensure FedRAMP compliance, then you get approval from basically the powers that be in the federal government that you're compliant with their standards. So that's what that is as well. And they have similarly, like CIS has level 1 and level 2. DISA has, I think it's DISA and the Department of Defense have defined different config levels for critical classified information, mission critical public, etc. And our friends and partners over at MITRE actually do a lot of work in the inspect space and partner with us on a lot of the more stringent configuration settings for the US government. So they do some really, really good work in that space.
Interesting.
It is, and it's not that you're going to deploy every single setting of these config recommendations, but it's just a good starting point. I think these profiles get you maybe 80% of the way there. And actually, let me show you what we have for, for example, for Docker. So we have an example Docker benchmark profile. And inspect work, so if you think back to what we were chatting about at the beginning, so inspect takes inputs, so these are the inputs, and it understands how to run those checks, and then it has outputs. In terms of the inputs, this is Chef's content, but there's a ton of amazing open source content that you can leverage out there. MITRE has open sourced a whole bunch of these profiles on behalf of the federal government and with the blessing of the federal government. I'm trying to think who else. There's a lot. You saw the DevSec hardening framework team. They have some really good open source content that you can leverage as well. And that content is out there. It is, if it's open source and it's indicated that it's free to use, you can absolutely leverage that and use it as an input to your inspect profiles. So it's pretty cool and flexible from that perspective. And, stronger together is what I think of when writing inspect profiles, because the check that I write might be helpful to you all, in a few months' time. I think the more inputs we have into the content, the better. So, for example, the Docker container checks. Docker container, this is actually a really interesting profile, and I'll tell you why. If you look at this, restricting network traffic between containers, there's a few different sections to this. So when you're running Docker on a server, there are certain checks and balances, such as restricting network traffic between containers that you might want to run. Running checks against your actual containers themselves and the images that you're building is actually a different section of this. And the section of those checks starts down at section 4. And I'll just show you really quickly.
You've been working a lot with Dockers recently, Neve. You have that memorized.
Yes. I've done a lot of work in this area. It's kind of interesting because the way that Inspect achieves this is really cool. So, for example, using trusted base images for containers. I don't know about you all, but when I first started playing with Docker and with containers, I was just pulling down the Alpine container image and building stuff on top of that. And I think that's pretty typical. More often, though, if you're building containers properly at scale in production, you're going to want to build your own container images from scratch with just the stuff you want in there. And so what you can do is you can tell Inspect to make sure that a container image is not built from some random image that somebody found online. enabling content trust, making sure that there's a health check instruction for your container image. So section 4 of the Docker profile is really all about like building the image. And then section 5 is, and typically as part of the pipeline, what we'll do is we'll run an inspec exec command against the image, excuse me, and then we'll actually start the container and run checks against the running configuration of the container as well. So you can plug inspec in at different points along that pipeline. And similarly with Kubernetes, to be honest, there's similar checks and balances that you can run against Kubernetes environments. If you're managing your own hosts and pods and you're courageous like that, there's checks you can run for that, but there's also other checks. Inspec essentially integrates with kubectl commands, and it can parse Kubernetes configurations and similarly make sure that they're secure. And the point there is, like, a lot of these they're fairly straightforward, but making them programmatic and giving the ability to version them properly and test your configs prior to deployment, it just makes life easier, right? I've been in scenarios where I wasn't doing things in an automated fashion and accidentally deployed the wrong thing. And that's really the situation that we want to avoid. And there's one other thing I want to just highlight in terms of test kitchen. Not that test kitchen. Search engine optimization at Chef is really interesting for what it's worth.
Yeah, I bet it is.
Get all kinds of things. So just really quickly, Kitchen CI, it's functional testing for infrastructure as code. As you can see here on the right, it integrates Ansible, all kinds of different platforms, super flexible. You can actually leverage solutions like server spec with it, but I think a lot of folks are using Chef InSpec. So would you use this to do your deployments to AWS? Probably not, right? But you might use it to do just a very quick local check on a configuration that you want to deploy locally on your laptop. And what I mean by that is if you had a CentOS config that you wanted to deploy and you have a CentOS image that you have local on your laptop, you can use Test Kitchen to just spin up a quick container image, run that cookbook, make sure it does what it needs to do within spec, or run an Ansible playbook and then ensure that config within spec and then spin it down. So even before you start committing things to code and doing a pull request, you can run this through this quickly. So
it's actually pretty cool. I like this. Oftentimes when I try to do infrastructure as code, it can be very time intensive where you add a resource, you deploy it to make sure it works, tear it down. Then you add another resource,
yes,
put it up, tear it down, right? And so this actually makes it a lot faster and easier to be able to do that.
Yeah, and obviously it depends on what you're deploying, but the reason I brought up the container locally on the laptop for exactly that reason, Braeden, because honestly, by the time you deploy a full stack and configure all the things out in the cloud, it could take a while. With Windows, I'm not sure there's like any easy way around all of that, but at least for Linux images, for sure, on Mac you can run this really quickly and easily. This would be basically a step before something like Packer, right? So you can use it to do testing on your Ansible playbooks or your Chef cookbooks. There's a lot of different scenarios and plugins as well that you can use. So cool. Okay. Where to from here? Just really quickly on the Chef infrastructure side. So we talked a little bit about what configs get deployed where. And this is where we're really going to start talking about how do you get really specific about what set of configurations gets deployed at which point in time. So when you're getting out the door with Chef, there's a couple of things that happen. In our training online, we show you how to manually bootstrap a node, I think, and run a set of cookbooks. So, and that's fine. But if you were deploying at scale, there's a couple of different ways to do that, and you can do either or both of these approaches. essentially, you can build an image using Packer, and that's what we're going to run through today, and using pipeline testing and deployments and updates. And the reason that we like Packer at Chef is essentially you can go out and use a source AMI or run a filter check against a source AMI and use that as the source image for what you're deploying. Apply whatever configs it is you want, do a test against that with Chef Inspec, and then bless that AMI and publish it for everybody's consumption. And then when you're doing your actual deployments, whether it's CloudFormation or something like Terraform, what you can tell those deployment mechanisms to do is essentially leverage the latest version of that particular AMI. When we're using Chef in the image build process, what we do is we like to use an approach called Chef Client Zero. So essentially, rather than telling Chef to go and check in with the Chef server, we use a bundle or a set of cookbooks, and we run Chef Client -Z and point the Chef client to a specific set of cookbooks. Within a pipeline, you can have those cookbooks as part of the code in your pipeline. You can point the pipeline to a particular GitHub repo for those cookbooks. So for example, if we look at Chef OS hardening in here, if you were running, for example, the OS hardening as a step in building your AMI, you could have a step in the pipeline that just points directly to this particular GitHub repo, or you can just have the cookbooks themselves as part of your deployment repo as well. So it just really depends. Once you've built your image and you're deploying that over and over, typically what we'll do is we will lay down a script in our user data, in the user data file. And actually our documentation has a really nice example about how to do that. So if we go in here really quickly, I'm just going to search for user data. I'm pretty sure it'll come up. I could type today. Bootstrap a node. So this is the workflow for bootstrapping a node. I'm just going to scroll down really quickly, and then we might zoom in again because I think it defaulted back to the original resolution. But right down here at the bottom is an example user data script that you can absolutely use with your EC2 instances. A little bit too big. There we go. Unattended installs. And the reason I'm highlighting this as well is essentially we have this concept called firstboot.json. And what that does is it runs a specific set of cookbooks at first boot. So if you had a, for example, a Windows server and you wanted to add it into the Active Directory domain at first boot, what we can do is we can go through and run a set of cookbooks to lay down the Chef client, configure it as a scheduled task, and then add the server to the domain, reboot the server, and then pick up where we left off and continue on our merry way. And in our client.rb, what we can do is we can specify both, well, as part of the script, we've specified the firstboot.json, which is really straightforward. As part of our client.rb, what this does is this basically lays down, if you're bootstrapping a node and pointing it to a specific Chef server, it lays down those configurations. Chef typically looks to a couple of different settings in order to establish what the node name is. And then what you can add in here as well is, we talked a little bit about policy files, but if we look at the code for those, what they are is they specify exactly what cookbooks you want to run and when to run them. So if we look at them, the goal with this is not everybody's going to be a Chef developer, right? Or know how to update or write a cookbook. With policy files, what you can do is you can be very specific about which versions of a cookbook you're running. And then you can set in override parameters for certain things that are being configured. And what we're setting up here is we're saying, hey, what I want to run on this particular node is Chef client is going to basically install and run itself. We're going to run a remediation cookbook, so a hardening cookbook, and then I'm going to run an inspect check. And that's what that audit wrapper is doing. We've actually updated that capability last month to really make that a lot more streamlined. But when we define this, basically we create a lock.json, and you can actually do, there's a quick command that you can run against your cookbooks that will create a tarball of those cookbooks. And you can run that as a standalone bundle as part of a pipeline or within a server that's, somewhere else that doesn't have access to the chef server. There's a number of different ways to run that. Or you, within this client.rb setting, what you can do is you can specify exactly which policy file you want that particular client to use. So you can tell it, hey, you're a member of DevRel, and you're going to use this particular policy file, which in turn defines which cookbooks get run. So the reason behind all of that, chatting about that stuff was, so when we go into our pipeline overview, you guys understand what we're doing here. So there's a number of different components to this pipeline. So in this particular directory, and by the way, actually, I should probably flip this to public, seeing as I gave you guys the URL. I will do that right after this show. But basically, there's a few different sections in here. So CloudFormation is, this is just essentially the YAML file that defines your code pipeline that's going to build our AMI. And that pipeline has a number of different stages. You have to be able to obviously create and update a pipeline with the user who's running this particular CloudFormation template. If we scroll down, you'll see that we have a validation step. So we're going to check our Packer template, and I'll show you what that looks like. So validate template, that's just a basic syntax check, nothing too...
Eva, we can zoom in once more. I think we zoomed out. Maybe one more time. See if that...
How does that look?
I think that looks, I can read that. So if you all can read that or can't read that, please let us know in the chat. But thank you for bringing that up.
Thanks, Braeden. So the first step in the pipeline is essentially validating the Packer template. The second step is actually building the AMI. And this is the step where Chef really plays a part. Essentially, Packer has a number of different ways to leverage Chef. In this particular example, we're using a mechanism called Chef Solo, which essentially just looks in a specific location for a set of Chef cookbooks to run against your AMI. Then we go and we test the AMI. I was joking with Braeden and Stuti before the session that my tests are actually failing right now because the EC2 instance for testing is not deploying correctly. It is determined to hard code an EC2 instance ID for I don't know what reason, but we can take a look at how we troubleshoot that. And then finally, once we've passed all our checks and balances, we publish the AMI. Now, at the beginning, I showed you that quick diagram around running this as part of AWS. If you're in a hybrid situation where you're still running potentially some VMware images and you're on-prem, or you're running VMware within AWS, you can absolutely leverage Packer and Chef to build VMware images as well. What this allows you to do is just essentially take a source image. So say, for example, you want to do an image build once a month to have fresh images, or whatever condition triggers an image build. Basically, what you can do is you can take the previous last known good image that you had and use this mechanism to update that image. So rather than having to remember to do all the different steps individually or manually running a Chef cookbook against something, this is just a lot more scalable and a lot more robust. And this pipeline, when we deploy it through CloudFormation, essentially it looks at it looks to GitHub, but you could point you could point to any repo essentially with the AWS code pipeline, just as long as you provide access and the ability to read that repo. So if you go back into the overall structure.
And Neve, let me interrupt you here real quick, since it's been about an hour since we started the stream. I noticed that quite a few have joined midstream. So real quick, reintroduction of what we're doing here today. This is Howdy Partner, and we have a weekly episode to be able to introduce partners' innovative solutions built on AWS and can be implemented with AWS. So today we have Chef, and we have Neve representing Chef, and we're talking about Chef Inspec, which is going to help automatically go through to make sure that all of these configurations for your servers are in line with compliances. And then of course later we'll also be talking about building AMIs programmatically, which we're hitting on this topic right now. So I just wanted to catch everyone up to speed for those who joined midstream. And then Neve, why don't we go ahead and let you get back to it? Yeah,
absolutely. Thank you. Because if you dropped in right in the middle of this, it might be a little bit confusing for sure. So the overall flow is really, you pull the latest version of code, obviously. The pipeline validates the Packer template. We build the AMI, and then we launch a test instance, which is the step that's failing in my pipeline. And then we test the AMI using Inspec. And essentially, if we look at the build scripts, we can go in here. Actually, hang on. Sorry, I need to go into Packer. So if we look at the AMI.json, you'll see lots of different parameters in here, but they're mostly parameters that should be familiar to you all if you've worked in AWS with EC2 instances. You could use a source AMI. So typically what we'll do is, if I'm starting an AMI, building an AMI from scratch, and it's the very first time I'm doing a deploy using this mechanism, what I'll do is I'll start with a standard AWS EC2 instance and then configure it to what I need it to be. And the way the Packer does this is it essentially, it looks at the AMIs, it evaluates what source AMI it needs to use, it spins up an EC2 instance, and then in this case, we're using Chef to lay down and run a specific set of cookbooks. So we're using a mechanism called Chef Solo, and Chef Solo, in this scenario, Packer's just looking within the same GitHub repo for the cookbooks that it needs to run. Doesn't need to talk to a Chef server or anything like that. Basically, you can pass Chef Solo certain parameters depending on what you're doing. Obviously, you know, we're passing it sudo so we can lay down the correct configurations. And then once we've run these provisioners and we've built the image, you can actually, it doesn't show it here, but there's output settings for the AMIs that you're creating. So you can say create a new AMI and copy it around to all my different regions. So if you just wanted a base AMI for everybody to use across the regions, this is a really good way to go about it. And I was actually very pleasantly surprised when testing that publishing the AMI to all the different regions is actually really, really quick. And there's a builder parameter that allows you to do that. And even though your AMI is created with instance type, t2.micro, when you're actually deploying the instance, you can obviously put whatever sizing it is you want with that. The cookbooks that we're running in this case are just straight up Nginx cookbooks, so something very straightforward. You can also use Chef to lay down certain sets of packages, system packages and patches. Typically, what we'll do in this scenario is for Windows packages, we can talk to your WSUS server, or you can leverage mechanisms within AWS to query which Windows patches need to be deployed. With Linux, we can integrate with Red Hat package managers. Whatever package manager is that you're using, we can, within the Chef cookbook, you can tell Chef, hey, go out and make sure that these particular sets of patches are applied. And in fact, where to go and look for those patches could be an attribute like what we just showed in the cookbook and the policy file. So in your policy file for a particular image, you could say, hey, for this particular set of server images, I want to go and grab packages and updates from this location. So that is the AMI.json. And honestly, that is really the height of Packer's complexity at the end of the day. We use Packer at Chef to build our AMIs and copy them around. And it's just a nice way to keep everything current and up to date. Here's our cookbook directory. So pretty straightforward. Chef typically has a default cookbook. We always use Nginx as a straightforward example because it has standard files and well-known configurations that are used. And here's an example. So each of these, for example, the cookbook file, nginx.conf, cookbook file would be a resource or an example of a resource. Package, the way this works, this is actually really cool, and I want to highlight this. If you use the package resource, what this does is Chef understands what flavor of Linux you're on. So if you're on Debian, it'll leverage dpackage, or I am drawing a blank. I haven't had enough caffeine today. But basically, it'll use what the package resource does is you don't have to worry about which commands to run to install those packages. Chef understands that it needs to use the underlying yum mechanism to install a package on Red Hat or CentOS, for example. And then laying down the service, what will happen is, say you ran this and all of this stuff is already configured on the server image. Well, that's totally fine. If you think back to when we're first looking at what Chef Client does, it will run and it'll essentially leave all those configs in place, and it won't rewrite anything or update stuff that it doesn't need to. It will just ensure that the configs you want to have on the machine are there. And then the last step in this is your tests. So essentially all this is, we had the big compliance inspect profiles or lots of tests, but honestly, getting out the door with inspect for functional testing, this is where you could really start and be effective in terms of checking what actually got configured is, and again, this test/inspect, there's a ton of different integration frameworks that just understand they should look in this particular directory for inspect tests and how to execute them. So Test Kitchen knows to look in the inspect directory for inspect profiles, and it'll run these functional tests. So we see the Nginx package should be installed, it should be running, and after I spin up and run the cookbooks, it should be listening on port 80. You can also do checks and different parameter checks, making sure that you're not listening on port 80, that you're listening on port 443 or whatever port you want to specify, that you are running SSL. We can also validate TLS versions, for example. We can validate that your SSL cert is up to date. There's a ton of different checks and parameters we can run there. So what did this look like when I deployed it? So I deployed this stack before, by the way, you can see we are huge AWS fans within the Chef Solutions Architect team, because we use Terraform, we use CloudFormation, we use a lot of different mechanisms, but it's just so flexible and great in terms of doing everything. So what this CloudFormation template did is it went out and it creates essentially a pipeline. Actually, you know what? Not that stack. I apologize. It's this one. It creates a pipeline, and when the pipeline is essentially defined and laid down, it actually creates a number of different resources. So let's just take a look at those. So it defines a pipeline. It defines the roles that we need in association with those pipelines. It creates a code build project for us. The template also creates an S3 bucket and an S3 bucket policy. And what we do with the S3 bucket is essentially, as we go through all those different steps in the pipeline, what we'll do is we go through and we essentially store the output and the parameters in that S3 bucket. So in my case, the testing failed. I was able to go in and look at the outputs. There's a couple of different areas that you can look at where those failures occurred, and that S3 bucket was one of them. And then obviously the last 3 code build projects here. So there's no outputs, but these are the parameters. So as part of the parameters for this deployment, I essentially told CloudFormation which GitHub repo I wanted to use, what my GitHub token was, my GitHub username. It's pretty straightforward. So once I deployed that, what this looked like is there's 2 areas that really we look at in terms of status and how this is running. And if we go into services, essentially, I usually start at code pipeline because that's where the pipeline gets laid down and defined. If we click into pipelines, you'll see sad face, failed. So essentially what happens is every time I make a commit to the main branch or the master branch of my GitHub repo, which is this particular repo here, and actually, let me just zoom in a little bit more. There we go. The code pipeline gets triggered. The pipeline is watching that particular repo. So say, for example, I wanted to do an update to my cookbook, and I wanted to trigger an automated AMI build every time I saw an update to that cookbook. That's how you would do that. Basically, the pipeline will watch that GitHub repo automatically, or obviously you could watch the code commit repo as well in a similar manner, and it'll run through the different steps in the pipeline. And what it's doing here is it saw a new commit that triggered a pipeline or a pipeline build, and it went into validating the template. And if we click into details here, this is where it gets really cool. I love pipelines so much. Essentially, all the different steps that we're running through in the pipeline are output to our logs. And if something fails, you can go in and you can look here. And if we take a look at what exactly I was running, essentially, these are the different steps. So it's pretty straightforward. If you're used to running any kind of Linux commands, we're essentially parameterizing those and putting them into quantifiable and testable steps. Validate template is actually the first step in this. So as part of that, what we're doing is we're downloading Packer, and we're just using Packer to make sure that the AMI.json files are valid. So if you take a look at where we actually find those within our repo, it's under, so this is the repo that I was showing on GitHub. Under that repo, we have a Packer directory. We have the AMI.json, where we looked at this code already a bit, and then the AMI parameters. I'm going to share this repo with everybody. Couple of things to be aware of. In the parameters, there is, under its current version, this repo assumes that you have a specific VPC ID and subnet ID that you're using, and you do need to update those in the parameters. But essentially, the first step in the pipeline is validate our YAML file, and then the second step is these particular commands. So we're installing our prereqs. We're doing an apt get and update. We lay down some initial packages that we're going to use, and then we go out and we get the Chef development kit. I also want to qualify this. This is an older pattern. We've since moved to Chef Workstation, which is a lot more stable. So I do need to update that as well. But Chef DK, I mean, the goal here is to have Chef client and Chef inspec on the server. So it achieves that for the points of this particular demo. And then we go through, and it's, the way to run Packer, and you can actually do this locally from your machine as well. If you're not running in a pipeline, you essentially run Packer build. You can pass it variables, but then you just pass it that .json file as an argument, and it'll go out and it will look to see what source AMI should use, create the updates, and then deploy, build and store the updated AMIs. So if we go back and look at our build logs, So we lay down Packer, et cetera, et cetera, et cetera. Scroll down here, we unzipped Packer, and that was fine. One of the nice things about pipelines within Code Pipeline is it gives you a build project. Well, this particular pipeline gives you a build project for each particular step of the pipeline. I'm going to go back in and get more details on this. So what this did was it went through and laid down Chef and laid down Packer again to build commands because it's using a new worker instance. And then this is where all of the magic happens. So essentially, after we've laid down our pieces that we need in order to do this, we're programmatically providing an AMI name. We identified our source AMI. Packer typically creates a temporary key pair for the pipeline. So the next step after this, where my pipeline is actually failing right now, is Packer and the pipeline essentially SSHs into that, spins up an EC2 instance, SSHs into that EC2 instance, and then runs the inspect checks and whatever other commands actually that you want to on it as part of that test step. You probably don't want to have your own credentials knocking around in pipelines. Take it from me, I had bad things happen that way. So not terrible things, just inconvenient things. And so what Packer does automatically is it'll create a temporary key pair for you as part of the pipeline. And then it'll set the temporary security group to allow port 22 from our pipeline in, so we can build out our AMI. And so once SSH becomes available, it provisions with Chef Solo. It essentially goes, Chef Solo will, when it's run as a provisioner within a pipeline, it'll go out and install Chef Solo or Chef client itself. And then it will run the specific set of cookbooks that you want. And the default behavior, we're on Chef Client 17. It just came out last month. It has a lot of cool new capabilities. And so our default behavior here is to lay down the latest version of Chef Client. You can specify a version if you want to as part of these parameters.
A little tangent here. What's something cool that's included in the newest version, Chef 17?
Yeah, so you know the way I showed a cookbook and we were essentially what it was doing, and I didn't go into this lower level detail, but we were pointing it to a specific inspect profile to run as part of the Chef client run. We've essentially consolidated all of that functionality, so you don't have to have a separate cookbook to run an inspect profile. With Chef client, you just pass Chef client the inspect profile parameter.
Oh, cool.
Yeah. I'm trying to think what else. We put a lot of work into, in the last year, making Chef easier to use, because there have been complaints that Chef's a little complicated, and it is. It's kind of like looking at a cool garage full of tools and then trying to figure out which tool do I need to use in order to do the task that I have at hand. And really, we've been focusing on making Chef Client a lot easier to use and more streamlined between versions, but also in terms of upgrading Chef Client and running it in scenarios like what I talked about at the beginning, where you might want to run Chef as a step in pipeline or based on certain other things that are happening in your environment. And that's where Chef Client -C and that ability to run a tarball of Chef cookbooks independently is super helpful. And I'm happy to talk about running Chef with Habitat if folks are interested about that. That gives you a ton of different options and flexibility around that as well. Cool. So yeah, Nginx cookbook, it's an oldie but a goodie. I mean, it lays down Nginx, and so it's going through and it is doing exactly what we wanted to do here. What's really nice about, and things like the templating ability in Chef cookbooks. We can lay down specific files, change the ownership, be very specific about that. Action install, Chef knows exactly what to do, and essentially we're taking the package install action and laying down Nginx here, and then we are copying in the updated content. And by the way, say there was an index.html that was already there, and as part of your Chef Cookbook run, you wanted to update that, whether it's new content or you wanted to update your nginx.conf file. What will happen is those updates will actually get reported in to the automate layer, and there'll be syntax highlighting with a diff against them. And if you look at the Chef Solo configuration, so essentially this is the configuration that we use when you're running a standalone Chef job, but you can actually tell that particular configuration that you want to send the outputs over to Chef Automate, because all it's doing is essentially publishing the results of that Chef client run over into the Automate API. So it's all just through HTTPS. So, yep, we are laying that down. And then, obviously you can do lots of different things. What this is saying is we added in this particular line, we took out all of these lines, and then we laid down the Nginx service. And then once all of that is complete, this only took like very short period of time to run. And I'm happy to re-trigger the run as well, so we can see it go through its different steps. It created an AMI. It waited for the EC2 instance to stop, and then it created an AMI from that, and essentially published the AMI with a specific parameterized name. And if we look at, one sec here, at our EC2 instances and our AMIs, you'll see typically what I do is I'll take a timestamp and append them to the name of the AMI, so I know exactly what get built when. So these are all my AMIs that I built as part of our pipeline. And I'm in EU West 1 region, but you can just take Packer and configure it to publish to lots of different regions. And I actually have an example here of that. So we have a high performance CentOS AMI JSON builds that we use. And yep, this is the right one. So here we're actually just laying down Chef and other stuff on our AMI. So that's something else you can do. And we specify those scripts in our script directory here. And we have a source AMI filter. And then I believe it's the region setting that tells Packer, AMI regions, I'm sorry. If I wanted to take this output AMI and publish it to all the regions, I would just specify AMI regions and put in all the different regions you want to have that AMI published to. So that is the step that we are at here. And it just goes through and creates the AMI. Now, the next step after this is where things started to go wrong. And it actually wasn't.
I'm excited to see this.
I'm not. I'm not gonna lie. Let's go back into the pipeline really quickly.
So, as someone who has obviously deployed quite a few things using Chef and seemingly Packer, is this the way that you debug this? Is you're looking through that outputs, that terminal outputs, and reading exactly what's going on, that you don't really output it elsewhere? You're really going line by line there, huh?
Yes, but that's probably because I'm more familiar with just looking at Packer logs.
Sure.
There's absolutely nothing wrong with, for example, sending the logs over into LogWatch or something else and just handling it that way. It just had, I'm more familiar with just looking at pipeline logs, to be quite honest.
Sure.
In terms of So say something broke with Chef or Inspec, or a lower level error with Packer, it's probably more helpful to look in the pipeline logs. If you were trying to troubleshoot from, and actually what happened was something to do with EC2 instance IDs, at that point, it's probably more helpful to go and look at your AWS logs, which is what I'm going to do now. Yeah. So it kind of depends. Yeah, so this was like, no reason was provided. This is probably to do with how I wrote the pipeline, to be quite honest, because you probably want to catch the error as it's being deployed. And if we look at the CloudFormation error, the way this flows, it's kind of interesting. If we go back over to our code, and I'm sorry for jumping around so much here. We have our different YAML files for building for the different steps. And we have our overall pipeline CloudFormation YAML. What's happening in my case is we are running a test instance.yaml. And this is the step that's failing. So essentially we get to test_AMI, and it is called by this test instance.yaml is the next stage of the pipeline that gets kicked off. The problem that I'm having is this particular pipeline within a pipeline seems determined to use a hard-coded instance ID that is nowhere to be found in my environment. I don't know where it's coming from, and it's not in any of the output logs either. So I'm going to hunt down what is going on with that after this, and I'll let everybody know. But essentially what's happening in this is we're going through, and if we look at, so what we're seeing here is that AMI pipeline test instance. So what we want to do after we built our AMI, and we have our AMI, that cookbook ran well successfully on it, we were able to build our new AMI with Packer, and now we want to spin up an instance from that AMI and make sure that all the stuff is there and works the way that we expect it to. Within that step in our pipeline, that's where we'll call an inspec exec, and you can pass inspec basically anything you want to at that point. So that's what you're seeing here. And essentially, this is calling that local test parameter that we saw in the GitHub repo under the test inspec test.rb. But you can run inspec exec and call a GitHub repo if it's public. So say, for example, when we get into the serverless section, you can actually just call a GitHub URL, and that's how that particular Lambda is assuming that you're using inspec. And more often than not, it's either that or a set of tests that's local. In this scenario, we're using SSH to access the host, but you can actually layer different access parameters on top of one another. So say, for example, you wanted to query a SQL database that you updated. What you can do is you can pass an SSH parameter to inspec, and you can say SSH to this particular server, and then run a SQL query into this particular database that's on that server. And inspec knows I need to SSH first and then run the SQL command locally on that machine. Or not locally on that machine, against that machine, but remotely. And so there's a certain level of access that's assumed. Within this particular test step, what I'm doing is I spun up that EC2 instance in theory from my AMI, and then I'm SSHing to it, and I'm running that particular set of checks. You could also have do an inspec exec locally in this test, not the server test instance, but within your pipeline, and do an HTTPS query and parse output from that as well. So that would work as well. That would be another way of potentially checking that your EC2 instance is deploying the parameters that you want to. So pretty powerful from that perspective. And if we look back here, let's take a look at our events. You'll see exactly what I'm talking about. The CloudFormation template somehow always wants to see this particular instance ID, and I am not sure why. So I'll have to dig into that. But essentially what it would typically do is it would spin up a test instance run that set of inspect checks against it. If it passes, big old checkbox, the AMI is approved, and then it gets deployed or published. At that point, you could do your publishing of the AMI to your different regions if you wanted to. Essentially, folks are using these particular checks as gateways in pipelines in a number of different ways. So if you remember, the Docker parameter checks that we ran, that's how you would do that. It would be a step in your image build pipeline, your container images, and you can do an inspect exec and call the Docker profile a GitHub URL. So, I can just run it locally here too. So help. So inspect will just by default look locally for the particular checks it needs to run. But you can run it through, you can do an inspect exec through SSH and Git, HTTPS. There's lots and lots of different things. This particular parameter tells inspect to go and look at your Chef Automate server if that's where you want to keep and version your inspect profiles. But typically, I think what folks are doing are keeping inspect profiles either in their own GitHub repo, or they'll keep them as a particular parameter within or a particular directory within their AMI bills or their deployment pipelines. So let's give this a quick trigger. Here. So we can see it. Actually, let me just, I'm going to do a commit, and then we'll just trigger a pipeline that way. So while I'm doing this, are there any other questions around any of this? Is this helpful to folks?
Let's take a look. Leave a question in the chat. We got AWS or AS Warp saying, I didn't trust my EC2s to her 100%. So looks like that you got their trust, Neve.
Okay. That's good. Cool. Okay.
But this is, I definitely see the value, right? Like, I mean, just looking at this repo that you have here, just for this pipeline, like you got like tons of different scripts, and then you can have variables of variables, right? Where you kind of got things nesting. And so it definitely shows how complex, configuring a whole network of EC2s or servers in general can be, and making sure, and then on top of that, making sure that you're in compliance automatically, right? It's like, there's just so many layers to address that, it's very obvious here what kind of problem Chef is trying to address here.
Yeah, and I mean, it's Chef and CloudFormation and just infrastructure as code in general. And at the beginning of our session, I kind of mentioned about it's really how all these pieces fit together. I could take a Chef cookbook and explain it, but I think the flow is really important, and there's not a whole lot of collateral out there that describes the flow, soup to nuts, and how that works. What's nice about leveraging cookbooks, if you had Nginx deployed in different environments, you might have an on-prem test environment or something like that. You can have the same set of cookbooks, assuming it's the same Nginx configuration, which right. Obviously it might not be, but you can have a standard set of configurations that you're deploying across the board. And then Chef's hierarchical, so you can basically say, okay, here's my base config, but then for prod, I want to have XYZ thing. So I want to have a hardened instance of Apache, and I want to make sure that I'm deploying with specific parameters on my application load balancers or whatever that might be. And so you can version all of that. I think where it gets confusing is the difference between CloudFormation and Chef and user data. And there's all these different ways to do different things. And I found that this particular pattern works quite well, right, in terms of building AMIs programmatically. My test step notwithstanding, obviously. Cool. So what I did was I just did a quick update, and I'm going to create a pull request, or well, I'm just going to merge to master actually directly. The pipeline.yaml. I'm going to add this in. By the way, it's saying 9 errors, but it's just because it doesn't really either. I don't have the CloudFormation plugin installed properly. It's seeing it as YAML, which is why that is happening. So I just did my, I created commit, did push that commit, and now I'm going to just push it up to GitHub. So that's what I'm doing here. And then as soon as the AWS code pipeline sees that update, it will start to build automatically. So sometimes it just takes a sec, depending on when it checks. And while we're waiting for that to happen, you'll see in here there's different build projects. So these are the different steps in my pipeline. So you'll see all of the different steps actually worked no problem until it came to the test AMI. So validate is pretty straightforward. You can go in here, and this is just another area to look at what exactly this was doing, and what the submitter was, how long it took. And I know I mentioned about basically leveraging or where to look in order to see those errors that were happening. And let me just check to see if that pipeline is, yep. So it is in progress right now. So as we're going through, you'll see you can actually click into the details. So it saw the commit, it's validating the template. So it's sitting there and chugging along. We can go in and see, you can actually tail the logs in here as well. So what it does, the way the pipelines work, for all of you who aren't deeply familiar with this, we spin up a container in order to execute each of these steps. So that's why we need to tell the pipeline that it has to install Chef and it has to install Packer and all that other good stuff. So obviously it was chugging along in the background. It finished that phase and went through and it validated. It installed Packer in this particular build phase, and then basically said, yes, this is a valid template. Now, you can tell the pipeline to have your own container images. So one step to make this simpler would be to simply tell the pipeline to use a container image that already has Packer on there. And if we go back in here and back into our pipeline, you'll see we've gone to the next step, which is building our image. Come on, logs, you can do it. Typically, it'll show streaming logs. There we go. Yeah, so we're going through installing our prereqs. Setting everything up. Installing our Chef development kit. Pre-validating our AMI name. So one of the things I'll say, Braeden, around, leveraging this approach and it being complicated, it is complicated, but once you have the framework set up, you can rinse, lather, repeat at will. And I think that's the point. I often see these jokes online, especially in the programmer humor around, Oh, well, I spent 6 hours automating the 1 hour task.
That's me, right here. That's me.
It's me too. I mean, I like my job, so but there is an element of truth to that. I will definitely recognize.
But you're so right, though, right? It's all about like not just automating that one time 1 hour, but it's the repeatable things that you do 100 times. That it just keeps getting better once you do it that first time. I always like I'm sure that a lot of people have heard the analogy that they say if you have an hour to chop down a tree, I would spend, X amount of time sharpening the axe, right? And like, and I enjoy that. I think that to some degree it's true, but I think a lot of people can sometimes get misled in thinking or may not, let me say this. Sometimes they don't know how to properly sharpen the axe. What exactly does it mean to sharpen an axe in each instance? In this instance, it could mean, oh, you know what? Automating it is sharpening the axe. So therefore, in the future, I can chop down not just this tree, but in other trees as well. So that's something I really appreciate about, what's being done here is that you're sharpening your axe, not just for that one tree that you've been asked to cut down, but for other future trees as well.
Yeah, exactly. And honestly, there's laying down the foundational pieces and getting out the door. And then I think my goal always when I'm working with everyone, and we chatted about this in the beginning, where we do a lot of paired programming and that kind of thing, is not that everybody should have to come in and create all of this from scratch. It's really, what can you do to set it up so that if somebody who's not a deep level expert in all of this can come in and make certain changes on their own and be confident that it's going to be tested and deployed. And if it's not correct, that it won't deploy. But that's where if you set things up, and this is, take the word chef out of it altogether. I think if you set things up in a certain way, you can make that easier for folks, right? Because everybody has to start somewhere. So I think that's key as well. So cool. So it's creating the AMI. So while it's doing that, let me show you where I troubleshot my previous failed deployments. So essentially, if you go into our S3 buckets, you saw as part of the pipeline, we create an S3 bucket and we store the stuff. And as part of the outputs for the second stage of the pipeline, we store the manifest.json and a couple of other things in that particular output. Now, if we look down here, we'll see this is my S3 bucket, and I have my stuff for my AMI builds in here. And essentially, each time I'm going through and running the build, if there's an error, or if I want to look at the specific files and configs that were being used as part of the pipeline, they get laid down in this S3 bucket. So if you wanted to go back and double check what exactly was being used, so not necessarily, hey, there's a log and we ran this application, but more, when I was passing in certain parameters into the pipeline, where exactly what exactly were those parameters, and I'll show you what this looks like. So, in our beginning repo, we had a number of different directories, and so this is what ends up in the S3 bucket. So we have the installation files that we want to lay down, so Packer and Chef. We have a test instance key. You may or may not want to keep that in that S3 bucket. We have build scripts and build spec. And then this is the additional file that there's a couple of different additional files that get laid down in this S3 bucket that are interesting, because I was having issues with the instance ID and trying to figure out. There's a manifest.json that gets built that basically specifies what all parameters were we using as part of Packer. And then there's the test instance config.json. So this is the AMI ID that we're using for the test instance. And this is the key ID that we're using. So you'll see the key ID matches the PEM file, that we would use to SSH in to test that. So it's just additional things that you can check and look at if you're having issues. And obviously that depends on how you've defined your pipeline. So as we go through here, let's go back to our code build. We're still waiting on that to chug along. So it takes a few minutes to build an AMI. I mean, Windows probably takes a little bit longer again. But obviously this is something that's just essentially, a standard process. And if we look at our CI/CD pipelines, now this is very small. Let me just really make this a lot bigger. What we're typically doing, and this is where we're integrating with Packer and other stuff if you want to, what you can do is you can actually run an inspect check on your source AMI if you want to. You are laying down, you'll have typically a chef cookbook that's your base cookbook that lays down the stuff that you want all of your servers to have. And typically we have one version for Linux and one version for Windows. And then you can have an image patch baseline. And the reason I'm bringing that up is if you want to be consistently sure that you have the same set of patches across your machines, this is a good way to go about it and just one way to approach it. And if you give me one sec, I am going to bring up my patch diagram that I have, I hope, here. Maybe I don't. Give me one sec. Just to show you the workflow. So typically this is the way it would work. So we have our nodes, they're sitting there, but nodes under management could mean ongoing running servers, but it could also mean just actually part of the pipeline. That chef client could reach out to your patch management environment and figure out, bring down whatever patches or patch set it is that you want to deploy, apply that, and you could have that as part of your pipeline as well. And then in terms of deployment, if you have a set of servers that are long running out in your environment, so this is not the immutable infrastructure use case, but if it's just regular servers, what you can do is you can actually use inspect to do pre-flight checks. So what you can do is you can run a quick inspect check in your environment to validate, do I have enough disk space on my machine to run a patch? Is everything healthy? Do I need to, for Windows, do I need to reboot the machine quickly? So if you're running a traditional server environment and patch management is one of the challenges that you have, you could definitely leverage Chef for that. Let's go back over to our pipelines. See what it's up to. Still chugging along. Completed. Yay. Go back up to build projects. You'll see this is in progress still, but I'm going to bet my bottom dollar that this is gonna barf. Yeah. Okay. I'm going to get this fixed. So what this is set to do is basically roll back if it's not able to deploy the resources correctly. So I would hazard a guess it's something to do with a pipeline within a pipeline, creating an instance. At Chef, what we do, I don't know, Braeden and Stuti, if you guys see this, if you guys see this within other people's environments, but we use tagging to make sure that we manage our costs. So if you look at, so one of the things we do when, if you look at basically any of the resources, this is a stack that I spun up for our demo in the front end. We can look at the Chef Automate EC2 instance. We have programmatic tags. We use time to live tags. And 72 is the number of hours. And we have a when we look at lambdas, so in one sec here, I'll pivot over to the lambdas. We have a Reaper process that goes around and tears down all of the resources that have been long running. So that is something that could possibly be going on with that pipeline as well. Maybe my resources are being torn down before they can even get validated. So with all that being said, there's so many different ways to run InSpec. I mean, it is super flexible. I really like it. And there's a lot of different work going on out in the field around InSpec. What I'm going to show right now is another way to run InSpec. So clearly it's a step in a pipeline like we showed. There's lots of different reasons you might want to run a quick InSpec check based on certain parameters, right? And that could be part of a pipeline. It could be part of an application deployment that you're doing. There's lots of different scenarios. And what we've done is come up with a Lambda function that allows you to do this. And essentially what we've done is basically, and this is a quick, I need to update the Ruby version in this as well. So it's a very quick example of using InSpec with serverless. So basically, we've defined our function. And by the way, I am not a Lambda expert by any means, but InSpec's fairly straightforward. So what we did was we created a Lambda function that is based on Ruby, right? And that function is essentially, if we go in and take a look at it, it's pretty straightforward. And think about this in terms of inputs and outputs. And the handler.rb here, come on. I was showing it earlier. Basically, it's essentially an InSpec exec. And what it's doing is it takes configuration and environmental variables. So if you think about at a basic level, you have where you're running your InSpec profile from. This is actually part of the work is based on work that the wonderful folks over at MITRE have done. So that's where this example comes from as well. But essentially, this is calling an InSpec profile, and this could be a local file that the Lambda has access to. It can be a GitHub URL. There's lots of different parameters that you could add in here, and then an S3 bucket to output the results. But basically, the trigger could be, if you're thinking about inputs and outputs, the trigger could be a pipeline. It could be we've seen a certain log come across on a particular set of application logs. And in terms of destination, you can actually go in and write the output to a lot of different locations. So if you look at, let's take a look at our docs really quickly. Not that I want to bore everybody with docs, but if we look at InSpec for the cloud, you'll see in terms of inputs and outputs. So our inputs can be lots and lots of different things. There's the controls and what we want to check for, but also we can specify exactly how we're checking for something. So, an InSpec exec, which is exactly what that Lambda is doing, and just essentially run a query to application layers. It can run a query to any kind of web front end, that kind of thing. And it really, allows you to do a lot of different things. And I think it's the DSL that allows us to, if you look in here, there's lots of different settings that you can leverage. So you'll see if you start to use things like Postgres session, InSpec understands that it needs to run SQL in order to in order to query that. And there's certain parameters that it accepts as defaults, but then you can customize those as well. And then on the reporter side, so if you're doing an InSpec exec as a Lambda function, the default reporter is typically up into Chef Automate, but we support all of these different outputs. So you can output it to YAML, you could output it to JSON, you can create your own web page, you can create a JUnit file. There's lots of, you can have multiple different parameters as your reporter options as well. So CLI is helpful if you were running an inspect exec check as part of a pipeline step. And then if we look down at automate reporter, this is how you would send your inspect output over into your automate URL layer. So typically what we'll do is we'll put in an API token in here. And again, that could be a variable if you're running this as part of a pipeline and you're specifying a reporter configuration file. So hopefully that makes sense to everybody.
I think it does. And I apologize, I didn't probably give you enough warning here. We should probably wrap here in the next 5 minutes here to help anyone that's going to be coming on after us to kind of get prepared here. Real quick, well, let's see. Was there anything else you wanted to hit before we go ahead and summarize everything for everyone, Neve?
No, I think I did a ton of talking, and thank you for listening to me. I appreciate it.
Well, to summarize for everyone, thank you for joining Howdy Partner, where we bring on a partner from the APN to highlight their innovative solutions. So today we talked about a couple of things. We talked about Chef Inspect, making sure that we're always in compliance and have automation built around making sure that certain configurations are set in place. And then building AMIs programmatically, right? It's making sure that we have a hardened AMI that we can build and then share with our teammates. So with that, we're going to go ahead and wrap things up. Stuti, I know it's been a little bit, but do you want to share with Neve what it looks like to sign off here at Howdy Partner?
Yeah, of course. I think we have 3 slogans. Not on top of my mind, though. Would you mind sharing those 3 things quickly?
So the way we sign off is we got 3 different sayings, Neve, and you get to pick which one. So you got happy trails, y'all come back now, or giddy up.
I'll go with giddy up.
All right. So on a count of 3, we'll say giddy up and we'll sign off. Neve, thank you very much for coming. This was very informative. A lot of people were very excited to see this. So with that, please join us next week at 2 p.m. for another show with our next partner. And we look forward to seeing everyone once again. Neve, hopefully we'll see you again on the show again in the future.
Yeah, I hope so. Thank you for having me. I appreciate it.
Absolutely. All right. So 1, 2, 3. Giddy up.
Giddy up.
Take care, everyone. Bye.
Bye. Thank you.
Bye. Take care, everyone.